What is a state of matter? This is a form in which matter can exist. There are four states of matter that are observed in our day-to-day life. We have solids, liquids, gases, and plasma. Plasma isn't as significant as the others, so we'll focus more on the other three for now. Solids have tightly packed particles that have no space to move. They have definite shape and definite volume. In liquids, the particles are packed together but not as tightly as solids and have room to move around. They have no definite shape but have a definite volume. Gases have loosely packed particles, and these particles can move around as much as possible. They have no definite shape nor volume. Changes of state are physical changes that are reversible and do not change chemical properties. The processes associated are melting, boiling, sublimation, solidifying, condensing, and deposition. In these changes, energy is always involved. These types of changes are caused by heating. In sublimation, a solid skips the stage of converting into a liquid and directly becomes a gas. These types of changes are caused by cooling. In deposition, a gas skips the stage of converting into a liquid and directly becomes a solid. A few ice cubes were placed on a plate and left on a table. I turned off the fan in the room and made sure that there was no excess light that played a role in this experiment. It was shot in time-lapse to help show the change in the state of matter, but at a more rapid pace. The experiment will be shown now. In the experiment shown prior, the ice cubes left in the plate melted. The room temperature stayed constant and no pressure was applied. The conversion of the solid to the liquid is called melting. If we were to keep the water there, it would evaporate and eventually turn to water vapor, which is a gas. This type of change would be referred to as evaporation. As seen in the figure on the left, particles of ice move further apart and are not joined together anymore. The particles can move around a bit more, and hence the state of matter after melting is now a liquid, as shown on the right. So, what is internal energy? This is a form of energy that exists in every single system. It increases with rising temperatures and with the changes in states, like solid to liquid or liquid to gas. Every substance has a fixed quantity of energy that depends on its chemical nature. This is known as intrinsic energy. Every substance has a definite value of internal energy and is equal to the energies of all of its constituents. Both kinetic and potential energy together make internal energy. The higher the temperature, the higher will be the internal energy. During the period of the ice melting, energy is transferred into the molecules of ice. The energy transferred in the form of heat increases the total internal energy of the ice. As listed before, the internal energy will be directly proportional to the temperature. Hence, when you heat a substance, the total internal energy will increase, which leads to the increase in the internal energy of the ice cube melting. There are four states of matter. These are solids, liquids, gases, and plasma. Solids have definite shape and volume, liquids have no definite shape but have a definite volume, and gases have neither definite shape nor definite volume. The changes in these states of matter are physical, and energy is always involved. In heating, there's melting, boiling or evaporation, and sublimation. In cooling, we have solidifying, which is another word for freezing, condensation, and deposition. Internal energy is a form of energy that exists in every system. Kinetic and potential energy together make up internal energy. Temperature is directly proportional to internal energy of a substance. The value of internal energy is equal to all of the energies of its components. Now that we have covered the topic, let's attempt a few questions to test your understanding. This is the end of the topic, states of matter. If you have any difficulty in understanding, go back through the video and watch it as many times as you'd like. For any more questions, please email me. Thank you.